Hello and welcome. Today I have a short video which I hope can help you when you want to write EPROMs on a TL866II Plus programmer which actually need higher voltage than the programmer can supply. The programmer TL866II Plus by XJQ is widely used and is an ultimate tool in every electronics workshop. It can be used as a tester for logic and memory ICs and as a programmer for various chips like PALs or EPROMs. There are different versions of the TL866 programmers, and I'll talk especially about the TL866II Plus today. However, the approach can be applied also on another programmers as well, I guess. So, regarding to this table from the official website, the TL866II Plus supports only up to 18 volts on the VPP rail. This limits the amount of writable EPROMs quite a lot, because many of them, especially the older ones, need 21 volts to enable the write mode. However, this should not hold you back, and it is still possible to write such ICs on this programmer. Let's take a look at this HN27128G EPROM made by Hitachi. This chip is not in the list of known ICs for the TL866II Plus. However, there is another very similar chip out there, with a suffix AG instead of just G. And that one can actually be selected in the programmer's software. This one can be programmed at 13 volts on VDD rail, as you can see. But if I try to program our G version of the EPROM by telling the software that we have the AG one, we instantly run into identification check assertion. This ID check can be deactivated. However, as soon as we move on, we will run into the next problem. The programmer tries to validate the written data but realizes that it hasn't been written, as you can see. This is due to too low VDD voltage of 13 volts, since this particular EPROM switches into the write mode only if the voltage on the VDD pin goes over 21 volts. You can find such information in the datasheet of the IC. Anyway, with an external power supply which can deliver 21 volts, we can work around this problem. As you can see, I bent up the VDD pin, which is by the way pin 1, out of the programmer's socket and connected plus pole of an external power supply to it. The ground pin remains in the socket and is also connected to the ground pin of the external power supply to have common ground between both devices. On the power supply, I set up 21 volts and limited the current to some very low value since it is only about the voltage. Back into the software, if we just select the program button, we will run into the pin control check, which is absolutely right since pin 1 is indeed out of the socket. Luckily, we can deactivate this check either and restart the programming once again. This time the software doesn't complain anymore and our EPROM gets finally written. I tested this way with many EPROMs and it worked like charm. If you don't have adjustable power supply like mine's, you probably would be able to use a notebook power supply which delivers enough voltage. I guess combining two power supplies to get over 21 volts would also work. If you go slightly over the value, I guess it would be also okay, but don't stress it too far. And this is it from me. I hope it is helpful for you. Just as always, put your comments, likes or dislikes below, and I hope to have you on my channel again. Thank you and goodbye.